In Cyprus, almost every day is a rainless day. On the island of goddess Aphrodite, the only water you will find in abundance is seawater. For nearly 2 decades, Caramondani Group has used its know-how to transform this seawater into fresh water. Based in the southeast of the island, the group uses state-of-the-art techniques to make the desalination process as energy efficient as possible.
The desalination plant was set up right here, on the Dhekelia beach. Caramondani Desalination Plants Ltd will be running it for 20 years. We started last year, and we will carry on till 2027. Here we draw water from the Mediterranean Sea, and we desalinate it. As you can see, there is a buoy over there, 600 meters from the shore. You can see it in red. The seawater comes in through a large pipe of 1.2 meters in diameter. It comes from the bottom of the sea, passes underneath the plant, and brings in about 120,000 cubic meters of water per day. When we were on the beach, I explained how we prepared the seawater with coagulators. Now, the water is cleaned or pre-treated up there. In that channel you can see, the water flows in from the sea, passes right beneath us, and into the gravel, sand, and anthracite filters, or dual media filters.
Dual media filters.
Now we're in the main plant. After the water has been cleaned in the dual media filters, it is stocked in 2 large underground cisterns. From there, we draw some water to rinse the dual media filters, and then it is directed to the security filters. We'll see those in a moment. The bulk of the water, most of it, is then directed to our high-pressure pumps. You can see them in blue. And there's also a standby pump. After the water passes through the high-protection filters, those green ones, at 6 bars, it is delivered to those blue high-pressure pumps and to the energy recovery devices. The pumps have a power of 2.2 megawatts each. That's 2,200 kilowatts. They generate a pressure of 70 bars, and they push the water into the membranes. After passing through the membranes, the water separates into 2 streams. The fresh water comes with 1 bar into a separate cistern, and the brine that carries all this residual power, a pressure of 65 bars, is canalized into these beautiful yellow machines. We'll take a look at them. They transfer that 65-bar residual brine pressure to new incoming seawater. This new water flows in from the high-protection filters with a pressure of just 2 to 3 bars, and a booster pump then adds 2 to 3 bars and brings it up to a total of 70 bars. Finally, the new seawater is sent back into the membranes. The old plant that used to operate here for 10 years consumed 9.5 megawatts of power. We've shaved off 4 megawatts. Thanks to these excellent devices, we now use only 5.5 megawatts. We've saved 4 megawatts or 4,000 kilowatts on our energy consumption, and that's crucial.
Look at
this device. It has no axis, no ball bearings, no pistons, no valves. Look at it. It rotates by itself as if it were on an air cushion. The brine comes in with its pressure. The seawater flows in too at the top at 2 to 3 bars, and you never need to open or close any valves. The 65-bar brine pressure transfers its power, and without mixing, the new seawater goes back into the membranes. This booster pump will add 3 to 5 extra bars of pressure to complete the cycle.
This room is the heart of the Caramondani plant. Located in the main unit, it allows the group to control every stage of the desalination process at all times.
The Dhekelia desalination plant is fully automatic operated, and we have here the possibility to check every single place of the plant, and we can, from this room, give all the orders and all the control to all the piece of equipment in order to make sure that everything is done automatic. From this room, we can go to any place of the plant, as it can be seen in the screen. We can go to the seawater pumping station, to the filtration, to the reverse osmosis, and we can do any control from this part. So it's very easy for us to control the operation of the plant, and also to make sure that we are having a performance that is in accordance with the design, but also that we have the optimum performance as regards to energy consumption, chemical consumption, and production in order to meet the client's requirements as regards to flows and quality.
These are the post-treatment filters. Part of the water enters these big tanks where it is then saturated with lime. The pumps take the water and send it into this compartment, where it is mixed with carbon dioxide. This gives the water its final taste. All the parameters we use are based on the European directive. They're the basis of our contract with the government of Cyprus.
Right next to the control room, in this laboratory, the water's quality is constantly monitored. In the contract signed with the government of Cyprus, Caramondani Desalination Plant has committed to respecting the European Union's quality standards. For example, the water cannot contain more than 1 part per million of boron.
Here, these are filtered with resin. They extract the boron. It's what we call the boron removal system. It extracts the boron from the water. This is the first plant capable of extracting boron from 30,000 cubic meters of water using these resin filters. What you see here is the secondary treatment or brackish water treatment plant, also called second pass. We take the water out of the main plant and we bring it here to be refiltered, so it becomes almost totally pure. It has less than 20 parts per million of dissolved solids, between 30 and 40 microsiemens. All this equipment was made by the Osmosis factory in Italy. It is part of the Caramondani group.
This energy-saving technology allows Caramondani Desalination Plant to double its production of fresh water while nearly halving its energy consumption. In Cyprus, where legend has it that goddess Aphrodite was born out of sea foam, Caramondani Group helps bring a sustainable solution to the island's water needs. With its 18 years of experience in the field of desalination, the group could extend the same solution to other shores, where, as in Cyprus, rainwater is scarce and seawater abundant.